డ్రింక్ బాటిల్ గ్లాస్
అంటే ఇప్పుడు ఎక్కడ సెట్ చేస్తుంటారు?
ఇప్పుడు మీరు ఆల్రెడీ మీరు ఉన్నారు కదా, కాబట్టి ఇప్పుడు మనం మెజర్మెంట్ ఇక్కడ చూసుకోవచ్చు కదా.
అక్కడే సెట్ చేసుకోవాలి.
అంటే మీకు వ్యూ ఎక్కడ వరకు కనిపిస్తుంది, మనం ఎలా తిరగాలి అనేది ఇప్పుడు చూసుకోవచ్చు.
మనం కనిపిస్తా ఉంటాం. దాన్ని నేను అనేది ఏంటంటే కెమెరా ఎక్కువ డిస్టెన్స్ ఆన్ లో పెట్టుకుంటే నేను బోర్డు మీద రాసేది అక్కడ క్లారిటీ ఉంటుంది. స్ట్రీమింగ్ వస్తుంది అది. నెట్ లో ఇక్కడ నుంచి నెట్ కనెక్ట్ అవుతుంది. నెట్ లో అక్కడ వాయిస్ వీడియోలో మనకి రాసేది అంటే క్లారిటీ ఉంటే మనకి యూజ్ చేస్తుంది. అంటే సపోజ్ బోర్డు కూడా వస్తుంది. ఈ డిస్టెన్స్ కూడా మీరు రాస్తే వాళ్ళకి క్లియర్గా కనిపిస్తుంది. ఇప్పుడు రాసేదంతా కూడా మీకు కనిపిస్తుంది.
ఆపోజిట్
మిర్రరింగ్ చేసుకోండి. ఇక్కడ వీడియో సెట్టింగ్స్కి వెళ్ళి ఇక్కడ మిర్రర్ మై వీడియో అనే ఆప్షన్ ఉంటుంది. ఇది డిజేబుల్ చేస్తే మనకి మామూలుగా అక్కడ వెళ్ళి రాసేటప్పుడు ఇక్కడ ఈ డిస్టెన్స్ అయితేనే మీకు బాగా క్లారిటీ కనిపిస్తుంది. బోర్డు మొత్తం కూడా కవర్ చేస్తుంది లాంగ్ పెట్టి. ఇంకా ఎంత లాంగ్ పెట్టినా కూడా బోర్డు మొత్తం కనిపిస్తుందని మీరు రాసే బోర్డు మొత్తం వాళ్ళకి చిన్నగా కనిపిస్తుంది. వాళ్ళకి మొబైల్ మ్యాక్సిమం స్టూడెంట్స్ ఉన్నారు. అందుకని రిపీట్ డిస్టెన్స్ పెట్టుకొని మీరు ఎక్స్ప్లెనేషన్ చేసుకోవాలి.
ఒక జూమ్ ఐడి మాట్లాడాలి. ఆడియో ఏదో కొంచెంసేపు ఒక 5 నిమిషాలు మాట్లాడతారు.
ఓకే
చూస్తారు.
ఓకే
తెలిస్తే వీళ్ళు రెడీ అవుతారు. అదొకటి. తర్వాత ఈ యానిమేషన్ ఎలా కట్ చేయాలనేది
it's a character action of nucleophilic addition. I request you not to write on the board. Somebody is disturbing unnecessarily. Somebody is unnecessarily disturbing. So with reference to these nucleophilic addition reactions, we studied how a carbonyl compound do react with hydrogen cyanide, follows how a carbonyl compound do react with sodium bisulfite, how carbonyl compound reacts with hydrazine, hydroxylamine, phenyl hydrazine, 2,4-dinitrophenyl hydrazine. These reactions we studied with reference to the nucleophilic addition. The special reactions of carbonyl compounds, what we are going to talk about today, are otherwise known as name reactions or special chemical reactions. These name reactions or special reactions are named by the scientists who invented these reactions. Today we are going to discuss about 4 special chemical reactions. All these special chemical reactions involves nucleophilic addition only. Clearly understand by one. very slowly try to understand. I think, are you getting my voice? I got it out. Can you message me, one of you? Slides and voice, audio and video. Is it clear to each and every one of you? Please, can you message me through WhatsApp? Okay, okay. Thank you. Okay, okay. Now let us, can you please stop this, what you call this, drawings on the board, on the screen, unnecessarily are drawing. You're creating the troubles. So now let us focus towards aldol condensation. First we see what is aldol, what is its mechanism, and what for this aldol condensation is used. Who undergoes aldol condensation? Because why we say that who undergoes aldol condensation is between the carbonyl compounds, we have both aldehydes and ketones. Even in aldehydes, also different aldehydes. Formaldehyde is the, which is simplest aldehyde, follows aliphatic aldehydes, aromatic aldehydes. Even in ketones, we have different types of the ketones: aliphatic ketones, aromatic ketones, mixed ketones. Mixed ketones in the sense aliphatic aromatic ketones. Among all these, who is undergoing the aldol condensation? As already it is said, aldol condensation. Aldol condensation is a nucleophilic addition reaction only. It is just a extension of nucleophilic addition reaction what we studied during the last class. Though it is a nucleophilic addition reaction, why it is named as aldol condensation is because the scientist Aldol is invented this reaction. Because of that, we say that this is aldol condensation. Now let us first look at what actually aldol. It may be a ketal also, because the scientist aldol is identified. Because of that, it is named as aldol, and it may be a ketal also. Generally, we call it as aldol condensation. Aldol may be ketal also. You could be able to read it from the slide. An aldol or ketal is a hydroxyaldehyde or ketone. Here itself, it is very clear. An aldol compound, you could be able to see both the structures, aldol and ketal, on this slide. Both aldol and ketal is consisting of a carbonyl group. Carbonyl group is must, but there is a hydroxyl group. Hydroxyl group and a carbonyl group is existing in the same molecule is known as an aldol. Ketal, what is ketal? Carbonyl group, that means a keto group, and the presence of hydroxyl group in the same molecule. It's what which is known as aldol or ketal. Or chemically, aldol or ketal can be called as beta hydroxyaldehyde or beta hydroxy ketone, more and more specifically. With reference to the beta hydroxyaldehyde, you see carbonyl carbon atom, that is the number one, which neither be labeled as alpha or beta. It is number one carbon atom only, carbonyl carbon atom. It is carbonyl carbon atom only. It's not, it is carbonyl carbon atom only. It is neither alpha nor beta. Carbonyl carbon atom, it is number one carbon atom. To the number one carbon atom, whoever is attached is known as alpha. Whoever is directly attached to the carbonyl carbon atom is known as alpha carbon atom. The hydrogen atoms which are attached to the alpha carbon atom are described as alpha hydrogens. Whoever attaches to the alpha carbon atom is known as beta carbon atom. and follows gamma and omega. But for this aldol condensation, gamma and omega are unimportant for us. We limit only to the alpha and beta. To the beta carbon atom, what is being linked is hydroxyl group is attached. This is what which is known as beta hydroxyaldehyde. Even in case of the ketone, you see, this is carbonyl carbon atom. This carbon atom, middle carbon atom, which is being lowered, is known as alpha carbon atom. The carbon atom which is attached to the alpha carbon atom is known as beta carbon atom. Now to the beta carbon atom, hydroxyl group is attached. So beta hydroxy ketone is ketol. Both aldol and ketol can be called as aldol. So aldol chemically is known as beta hydroxyaldehyde or beta hydroxyketone. This is what which is known as aldol condensation. Now, aldol condensation is a condensation reaction which produces, which prepares, which forms beta hydroxyaldehyde or beta hydroxyketone is known as aldol condensation. I think every one of you got this point. What actually aldol is, what the structure is. Now, simultaneously, do remember why this is undergoing the aldol condensation is only because of the carbonyl group, not because of anything else. Only because of the carbonyl group, it is undergoing the aldol condensation. Now let us focus towards the next slide. What actually aldol condensation is. As already just now I pointed out, compound or the reaction, a chemical reaction which provides, which forms beta hydroxyaldehyde or beta hydroxyketone is known as aldol condensation. Who undergoes the aldol condensation is, once again you are disturbing. I don't know what people are doing. What is this? If you continue in doing this, I skip out of the classes. What is this? Why unnecessarily useless fellow who is putting all these things? So with reference to the, what actually aldol condensation is, the reaction which produces beta hydroxyaldehyde or beta hydroxyketone. These beta hydroxyaldehydes and beta hydroxyketones are being produced by the aldehydes or the ketones which are having the alpha hydrogen. The one condition is the reactant. The reactant means, for example, if you take acetaldehyde, if you consider acetaldehyde as a reactant, it must
Sir, your voice is not audible, sir.
Sir, no audio is coming, sir.
Benzophenone is a ketone. Is it audible?
Yes, sir.
Yes, sir.
Hello?
Yes, sir.
Sir.
Yes, sir.
Yes,
Is
sir.
it audible now?
Yes, sir.
Can you SMS
Yes,
to
sir.
anyone of you?
Yes, sir.
Is it audible?
Yes, sir.
Yes, sir.
Okay, okay.
Night for a కనెక్ట్ అవుతుంది కొంచెం లేదు ల్యాప్టాప్ అయితే ఫాస్ట్ కనెక్ట్ అవుతుంది అందరూ ల్యాప్టాప్
Sir, your voice is not audible, sir.
Yes, sir.
Yes, sir.
Sir, your voice is not audible, sir.
Yes, sir. Yes, sir.
Now is it audible?
Yes, sir.
Yes, sir.
Now it's audible, sir.
Yes, sir.
Is it audible?
Yes, sir.
Yes, sir. Now it is
Hello.
okay.
Yes, sir.
Yes, sir.
ఇప్పుడు వస్తుందంటారా?
Yes, sir.
Yes, sir.
Thank you.
Yes, sir.
So this is an example for aldol condensation, where moles of acetaldehyde are condensed to get a beta hydroxyaldehyde or beta hydroxy. Molecules of acetone.
Again, it is not audible.
Your voice breaking, sir.
One is acetaldehyde, another one is benzaldehyde. One is formaldehyde, another one is acetaldehyde. And two different ketones. Two different ketones in the sense, one is acetone, another one is acetophenone. Or otherwise, one is acetone, another one is benzophenone. And the last one is one aldehyde and one ketone. One acetaldehyde and one acetone. Or otherwise, one benzophenone, another one is formaldehyde. These are the extensions points of the aldehydes. These are all undergo aldol condensation. Now let us look at the mechanism of aldol condensation. This mechanism actually involves only simple 3 steps. Very, very simple, not complicated. Those who could understand nucleophilic addition, it is very easy. Now we have taken a test tube. Into the test tube, we have taken 2 moles of the acetaldehyde and we have put dilute base, small amount of the dilute base. And we mix it well. When we mix well, what happens? The base gives OH minus anion. This OH minus anion is act as a base here, not as a nucleophile. This base act as a base. Here, the base is not acting as a nucleophile. We have to think it of. Now, with reference to this acetaldehyde, if you look at this acetaldehyde molecule, because of the reason that we have a carbonyl group, the carbonyl group, what the carbonyl group is doing is, the carbonyl oxygen atom is withdrawing the electrons from the carbonyl carbon atom. As oxygen atom gains a partial negative charge, carbon atom gains a partial positive charge. Now this partial positive charge carbon atom is pulling the electrons from the alpha carbon atom. To fulfill this deficiency, it is getting the electrons from the alpha carbon atom. And when it gains the electrons from the alpha carbon atom, there is an electron shift by the inductive effect. By inductive effect, these sigma electrons are slightly moving towards the carbonyl carbon atom away from the alpha carbon atom. Now, as a result, what this alpha carbon atom is doing is, this alpha carbon atom is trying to get the electrons from the hydrogen atom, asking the hydrogen atom to go away. Simultaneously, OH minus anion is approaching this alpha hydrogen atom. This alpha hydrogen atom is abstracted by the base. Because of that, we consider that it is acting as only as a base, not as a nucleophile. Now, this is getting abstracted. The hydrogen atom in the form of the proton is got abstracted, eliminated in the form of the water molecule. The electrons which are present in between, sigma electrons which are present between carbonyl carbon atom and carbonyl hydrogen atom is left over the carbon atom. Thus we get a carbanion. You need not remember the name of enolate ion. You could be able to remember it as a carbanion. A carbanion is formed. After the formation of the carbanion, the first step is conversion of one aldehyde molecule or a ketone molecule into carbanion by the removal of alpha hydrogen atom. Now, with reference to the second step, at the end of the first step, we got a product of the carbanion. Only one mole of aldehyde consisting of alpha hydrogen atom is converted into the carbanion, which is there as a reactant. Now, the second mole of aldehyde molecule is present. As usual, this is the nucleophilic addition reaction. First step is formation of the carbanion. Second step is nucleophilic addition reaction. That's what in the beginning of the class itself, I told you that it is just an extension, continuation of the nucleophilic addition reactions, what we studied during the last class, except the first step. First step is nothing but generation of what we call the generation of nucleophile, that is the carbanion. Now the carbanion would like to attack the carbonyl carbon atom because of the reason that oxygen atom is trying to gain an electron pair, pi-electron pair, which gains a partial negative charge. Carbon atom gains the partial positive charge. To overcome this partial positive charge, to make it neutral, to make the carbonyl carbon atom as stable, the carbanion is approaching. Now the carbanion, whatever the carbanion is possessing of electron pair, with the help of the electron pair, now a product is produced, nucleophilic addition product is produced with the negative charge of the oxygen atom. Now this negative charge of in the third step, as already we have taken dilute base consisting of the water molecule. The water molecule donates the proton. The proton is added to an anion which is produced at the end of the second reaction. Thus we could be able to get an aldol product. These are the three steps which are involved in the aldol condensation. So for this entire aldol condensation, two basic requirements. One is 2 moles of aldehydes or 2 moles of the ketones containing alpha hydrogen atom. Why alpha hydrogen atom is required is already it is visible in the first step. 1 mole of aldehyde, 1 mole of the ketone must be changed into carbanion. That is must be changed into the carbanion. To change into the carbanion, alpha carbon atom must be there, alpha hydrogen atom must be there. That alpha hydrogen atom must be removed during the first step. Then only we get carbanion. Once if we get a carbanion, the produced carbanion would able to undergo the nucleophilic addition reaction with aldehyde. We get an anion. It is not a carbanion, an anion is produced. After producing this anion, what this anion is doing is, anion is taking a proton from the water molecule, changing to beta hydroxyaldehyde or beta hydroxy ketone. And afterwards, you could be able to practice this aldol condensation for the different types of the aldehydes for different type of the ketone. Two identical aldehydes, two identical ketones definitely undergoes aldol condensation only. Now let us focus towards the crossed aldol condensation. There is a slight difference, only slight modification. Yes, already we discussed that two identical aldehydes undergoes aldol condensation, give aldol product. Two identical ketones also undergoes condensation, we get a ketal compound, that is also aldol condensation. Instead of that, now what we focus is, we take one aldehyde, one ketone. That means one acetaldehyde and acetone. Or otherwise, two different molecules of aldehydes. Two different molecules of aldehydes in the sense, one formaldehyde, benzaldehyde. One formaldehyde, one acetaldehyde. Two different molecules of aldehydes or two different types of the ketones are condensed together in presence of the dilute base. We get once again beta hydroxyaldehyde or beta hydroxy ketone. These products, this is known as crossed aldol condensation. But here, as we studied in the case of the aldol condensation, we don't get only one aldol product. Here we do get different types of aldol products, and different types of the aldol products are produced. A mixed aldol products are produced. That is what which is known as crossed aldol condensation. Is a cross aldol. Who undergoes the cross aldol condensation? As already I pointed out, two different aldehydes. One acetaldehyde, one formaldehyde. One acetaldehyde, one benzaldehyde. Out of the two different aldehydes, one aldehyde must possess necessarily, one must possess alpha hydrogen atom. The second one may possess alpha hydrogen atom, may not possess alpha hydrogen atom. And two different ketones. One acetone, another one is benzophenone. One acetone, another one is acetophenone. One acetone, another one is 2-butanone. And one aldehyde, one ketone. One acetaldehyde, one benzophenone. One acetaldehyde, one acetone. Like that, these compounds, two similar aldehydes only undergo aldol condensation. Two similar ketones undergo aldol condensation. Two different aldehydes, two different ketones, one aldehyde and one ketone necessarily undergoes a crossed aldol condensation. This is what crossed aldol condensation is. This slide is already I explained. The condensation reaction between two different molecules of an aldehyde or a ketone is a crossed aldol reaction. When condensation between two different carbonyl compounds, it is called as crossed aldol condensation. You see the examples for crossed aldol condensation. One acetaldehyde molecule is taken, and this is the one propanaldehyde molecule is taken. Both were taken in presence of the sodium hydroxide. A dilute base is added and mixed together, which gave almost 4 products. That means 2 acetaldehyde molecules react together, we get the first beta hydroxyaldehyde. 2 propanaldehyde molecules mixed together, we get the second aldol product. Acetaldehyde molecule, propanaldehyde molecule, thus we could able to rise 2 different types of product. Totally 4 different type of the aldol products are being produced. See the mechanism of crossed aldol condensation. Mechanism is similar. As usual, there is one aldehyde. Aldehyde reacts with a base, changes to carbanion. This carbanion attacks the carbonyl carbon atom. We get an anion. After getting an anion, the anion changes to the aldol product. This is what the crossed aldol condensation is. This is just like aldol condensation, not a different one. Applications of aldol condensation. There are a dramatic number of applications, and the industry exploited the aldol condensation reaction to like anything. The insect repellent, what we have been using in the present day, is prepared by the aldol condensation only. Not only this, in the cosmetic industry, jasmine is synthesized by the aldol condensation. And what we see, the carbohydrates like fructose is biological synthesis of the fructose also involves aldol condensation. So for this entire aldol condensation reaction involves 3 basic steps. One is formation of a carbanion. After the carbanion is produced, the next one is reaction of the carbanion with carbonyl compounds by nucleophilic addition reaction. Third one is conversion of anion into beta hydroxyaldehyde or beta hydroxyketone. As already several times I pointed out, the requirements of the 2 basic requirements. One fundamental requirement is 2 molecules of aldehydes or 2 molecules of the ketone, either maybe aliphatic or aromatic or mixed aliphatic or aromatic. Aldehyde or the ketone with alpha hydrogen atom. Second reagent is a dilute base at the room temperature. These are the 2 conditions. With these 2 conditions, we get the aldol product. The aldol is nothing but beta hydroxyaldehyde or beta hydroxyketone. Now let us move to the benzoin condensation. With reference to the benzoin condensation, let us understand what actually the benzoin is. Now, if you look at the structure is very visible that it is a benzoin. Benzoin is nothing but it is one is phenyl group, another one is another phenyl group. Between these 2 phenyl groups, I think already I am marking with mouse pointer. You could able to see this is one phenyl group. This is another phenyl group. Both phenyl groups are linked together with alpha hydroxy ketone, alpha hydroxy aldehyde. This is known as a benzoin. And benzoin is prepared by the benzoin condensation. a lot of benzoin and benzoin derivatives are there. And what I showed, the benzoin is fundamental benzoin, and this benzoin is fundamental benzoin. A number of benzoin derivatives can be prepared by the benzoin condensation. Benzoin also prepared by the benzoin condensation. Benzoin derivatives are also prepared by the benzoin condensation. This is also a condensation. Here also, two molecules of aldehydes condensed together, reacted together. And because of that, we call it as benzoin condensation. Why benzoin condensation? The name, because the scientist benzoin or otherwise benzoin product is being produced under the influence of a base. Under the influence of, once again, a base. The benzoin condensation, you see, the benzoin condensation, which is once again a nucleophilic addition reaction. This addition is between two aldehydes, no ketones. No ketones are pointed out. Only aldehydes were taken into consideration. Only aldehydes, that too two aldehydes. These two aldehydes are also aromatic aldehydes. You see, the conditions, the base is essential. The another one is two aromatic aldehydes are required. Benzoin condensation reaction is also called as a condensation reaction. Is defined as a reaction between two kinds of the aldehydes. Two aromatic aldehydes and condensed together under the influence of the base, it is known as the benzoin condensation. Now let us focus towards the benzoin condensation reaction. It is also a nucleophilic addition reaction. We have taken 2 moles of benzaldehyde in the first reaction, which were condensed under the influence of strong base, not dilute base. Now this time we change it to the strong base, because you may have a doubt that 2 moles of aldehyde was taken, and these 2 moles of aldehyde might have undergone aldol product, because here we have taken benzaldehyde. Benzaldehyde do not undergo the aldol condensation. Already I pointed out, because the benzaldehyde do not processing of alpha hydrogen atom. Because of that, it never undergoes aldol condensation. It undergoes the benzoin condensation. This under the influence of a strong base, like generally the base we use is cyanide anion. Sodium cyanide or potassium cyanide solution is added, which undergoes the decomposition to get cyanide anion. Thus, in the first reaction, it is very visible that the what you call this 2 moles of the benzaldehyde were condensed together. We get a benzoin. Benzoin is nothing but, you see, alpha hydroxy ketone, alpha hydroxy carbonyl compound. You see, at the lower side of this slide, as I am pointing out, there is a carbonyl carbon atom. To the carbonyl carbon atom, immediately adjacent to the carbonyl carbon atom, which is known as alpha, to the alpha carbon atom hydroxyl group is attached. But our earlier aldol condensation was beta hydroxy ketone or beta hydroxy aldehyde. This time it is going to be the alpha hydroxy carbonyl compound is nothing but a benzoin. With reference to this benzoin reaction, the 2 moles of benzaldehyde is taken. 1 mole of the benzaldehyde, as usual, undergoes the nucleophilic addition reaction with the cyanide anion, and we do get a carbonyl. You see, cyanide as usual, for the reason of minus electromeric effect. What is minus electromeric effect? Electromeric effect involves the pi electrons. It is going to be the temporary, and the electrons are moving towards the oxygen atom away from the carbon atom. Because of that, we call it as minus electromeric effect. Thus, carbonyl carbon atom gains partial positive charge. By gaining the partial positive charge, naturally it is electron deficient. It is considered as an electrophile. Now it wants to react with a carbonyl. It wants to react with a nucleophile. What is there in our test tube? The nucleophile is cyanide anion is the nucleophile. Now the cyanide anion is moving towards the carbonyl carbon atom. As soon as it moves, it is forming a sigma covalent bond. Thus, a trigonal compound is changing to a tetrahedral compound. The cyanide anion forms a sigma covalent bond with the carbonyl carbon atom. As a result, oxygen atom gains the negative charge. Because of the internal rearrangement, we do get a compound which is known as a carbanion. The hydrogen atom, which is directly attached to the carbonyl carbon atom immediately moves towards the oxygen atom with a negative charge as we get a carbanion, the carbanion. So 1 mole of one molecule of the benzaldehyde is now changed into the carbanion as usual, just like what we studied in the case of the aldol condensation. This reaction is similar to that of the first step of aldol condensation. First step of the aldol condensation generated a carbanion, but where the hydroxyl anion acted as a base, not acted as a nucleophile. But this time, cyanide anion is acting as a nucleophile and changing 1 mole of aldehyde into the carbanion, into carbanion. Product is similar, anion. There also anion, here also anion. But mechanism is slightly varied. Now, if you look at the step B, second step, there is another mole of the benzaldehyde. This another mole of the benzaldehyde undergoes once again nucleophilic addition because of the reason that the carbonyl group of the benzaldehyde, the pi electron pair is slightly moving towards the carbonyl oxygen. Carbonyl carbon atom is getting the partial positive charge. This wants to be compensated with the carbon atom of the carbanion, and thus this carbon atom of the carbanion nucleophile to bring the electron pair and forms an anion product. This is not a carbanion, an anion product. This anion product once again undergoes the rearrangement. This oxygen, the anionic oxygen, is trying to establish a double bond with the same alpha carbon atom. At the same time, at the similar time, cyanide anion, which already attacked, the cyanide anion is expelled out from the carbonyl carbon atom, as we could be able to get benzoate. You see, cyanide anion, though it is acted as a nucleophile, whatever the cyanide anion which is added, which is regenerated. What does it mean? Cyanide anion is not being consumed by the chemical reaction. It is just acting as a catalyst. Thus, we could able to get benzoin and benzoin derivative. We could able to start the reaction with 2 different types of the aldehydes, but 2 different type of the aldehydes must be aromatic aldehydes. When it is aromatic aldehyde, then only we call it as benzoin. Nitrobenzene can be taken, chlorobenzene can be taken, and we could be able to take the other type of the aldehydes and other type of the different type of the reactants, we get the different type of the benzoin. This is what which is involved. Here also 3 steps, there also 3 steps are getting involved. Now let us focus towards the what you call the third name reaction. Scientist Perkin identified or introduced this reaction, and we call it as Perkin condensation or Perkin reaction. In the Perkin reaction, the specialty of the Perkin reaction is we could able to get alpha beta unsaturated carboxylic acids. Alpha beta unsaturated carboxylic acids are produced. So that's what you could be able to read from the slide. The Perkin reaction is an organic reaction, which is also a condensation, which is used for synthesis of alpha beta unsaturated aromatic acid. Alpha beta unsaturated aromatic acid. By the condensation of who are getting condensed is one is aromatic aldehyde essentially, another one is acid anhydride. Acid anhydride may be acetic anhydride, it may be benzoic anhydride, it may be of propanoic anhydride. Any acid anhydride in presence of an sodium salt of acid. So under this influence, the Perkin reaction do take place. Now let us look at the Perkin reaction mechanism. For example, we have taken aromatic aldehyde. As already I said that two reactants are required. One is aromatic aldehyde. Another one is this time not 2 moles of aldehyde. This time we take only aromatic aldehyde. Only aromatic aldehyde 1 mole. The another is acid anhydride. Acid anhydride, which is a derivative of carboxylic acid. Carboxylic acid anhydride derivative is taken under the influence of the sodium acetate. Sodium salt of simple carboxylic acid can be taken. These are the two. Sodium acetate is acting as just a reagent. Acetic anhydride is acting as a reactant, and benzaldehyde is also a reactant. Both do reactants. These two reactants are condensed together to get alpha beta. You see, carboxylic acid follows alpha carbonatum and follows a beta carbonatum. Between the alpha carbonatum and beta carbonatum, there is a double bond, and thus we call it as alpha beta unsaturated carboxylic acids. Particularly, benzaldehyde changes to the cinnamic acid. You can try with nitrobenzaldehyde, you can try with the chlorobenzaldehyde, you can try with the bromobenzaldehyde, you can try with any other derivative of the aldehyde. And you can use acetic anhydride and you use sodium acetate. If you look at the mechanism, whatever the acid anhydride is taken, this acid anhydride do react with the sodium acetate. The sodium acetate decomposes to give acetate anion. This acetate anion, now it is acting as a base, not as a nucleophile. You think that there is a large difference between nucleophile and the base. And this base, the purpose of the base is to get back a proton. What the proton is being available is with reference to the acetic anhydride, one of the hydrogen atom. You see, this is the carbonyl carbon atom, and this is the what you call the alpha carbon atom. These alpha hydrogen atoms are very easy to remove. And now the base used to abstract out of, there are two ends, there are two alpha hydrogen atoms. It is only 1 mole. Only one of the proton is eliminated out. Thus we get a carbanion. As usual, we get a carbanion. Formation of the carbanion in all the special reactions is similar. Now a carbanion is produced. After producing this carbanion, now the next step is the carbanion undergoes nucleophilic addition reaction on benzaldehyde. We get an anion. After getting an anion, this anion eliminates water molecule. You see, this entire compound eliminates water molecule in such a water molecule as well as acetic acid. Acetic acid is also produced. See, by the elimination of the water molecule, that is this hydrogen atom and you see this hydroxyl functional group and this hydrogen atom, both will be eliminated in the form of the water molecule. Thus we get a double bond between alpha and beta carbon atom. And afterwards, the undergoes the hydrolysis in such a way that this is going to be eliminated out in the form of what we call acetic acid. And from the water molecule, it gains a proton. Thus, we could able to get what you call alpha beta unsaturated carboxylic acid. This is which is known as the alpha beta unsaturated carboxylic acid. And this alpha beta unsaturated carboxylic acid, which is being produced from benzaldehyde, is known as cinnamic acid. Now let us focus towards the last chemical reaction, which is a Cannizzaro reaction. The Cannizzaro reaction is not a condensation reaction. The Cannizzaro reaction is entirely different. It is an oxidation and reduction reaction, which is a combination of both oxidation and reduction reaction. Here, the aldehyde is taken. You could able to see very clearly. Aldehyde containing, earlier it is just opposite to the aldol condensation. Here we need aldehyde molecule containing no alpha hydrogen atom. Aldehyde molecule containing no alpha hydrogen atom. Only undergoes the Kenizarus reaction. These two under the influence of the concentrated base. Earlier we considered under the influence of the dilute base. Here it is under the influence of the concentrated base is taken, and under the influence of the concentrated base, what happens is benzaldehyde. When we take the 2 moles of the benzaldehyde containing no alpha hydrogen atom, one benzaldehyde molecule gives benzyl alcohol, another benzaldehyde molecule gives benzoic acid. Thus, when aldehyde undergoes the reduction, we get primary alcohol. When aldehyde undergoes oxidation, we get the carboxylic acid. Because of that, which is known as oxidation reduction reaction, that too, no oxidizing agent and no reducing agent is used here. Because of that, no oxidizing agent and no reducing agent is used. It is a self-oxidation and self-reduction under the influence of the dilute base. Because of that, this is known as self-oxidation, self-reduction without influence of none of the oxidizing, none of the reducing agent. This is identified by scientist Kenizaro. So because which is known as Kenizarus reaction. Now let us focus towards the mechanism. Mechanism is very, very simple. 3 steps mechanism is involved. As usual, we have hydroxyl anion. Hydroxyl anion, as already we discussed, concentrated base is taken. This concentrated hydroxyl anion, it acts as a nucleophile. Now the base is acting as a nucleophile. You see, nucleophile all the times it acts only as a nucleophile. The base can act either as a base, either as a nucleophile. Base in the sense which removes a proton is a base, or nucleophile in the sense which attacks, which reacts with the carbonyl compound, the electron deficient, electrophilic atom is nothing but a nucleophile. Now with reference to this first reaction, as soon as hydroxyl anion is there, this hydroxyl anion approaches the carbonyl carbon atom, acts as a base and changes to an anion. Now let us focus. This is as usual, but here an anion is produced. In all our earlier reactions, carbon ions were produced in the first step. In the second step, you see the second mole of the aldehyde is there. This is second mole of the aldehyde for the reason that electrons are getting withdrawn partially towards the oxygen atom and away from the carbonyl carbon atom. Thus, carbonyl carbon atom is electron deficient, which is electrophilic in nature. And the proton from the carbanion, a proton is from the carbanion, a proton is being abstracted. Thus, it is changed into another anion. And this anion 1 is changing into the carboxylic acid by forming a double bond with this, and simultaneously hydrogen atom in the form of the hydride anion along with a pair of the electrons, it is moving away. It is moving along with this pair of the electrons, it is moving. Because of that, it gains an anion. The another one is a carboxylic acid. Now, during the third step, this carboxylic acid ionizes to give H plus ion. This H plus ion moves towards the alkoxide anion, as we could able to get one alcohol, one carboxylic anion. And these two are most important steps. The first one is the generation of an anion. Second one is nothing but transfer of hydride anion from intermediate anion to the carbonyl carbon of second aldehyde molecule to get carboxylic acid and also to get alkoxide anion. The alkoxide anion, this alkoxide anion gains a proton from the carboxylic acid. Thus we could able to get an alcohol and also a carboxylic acid. Thus this class completes all 4 special chemical reactions, that is aldol condensation, cross aldol condensation, benzoin condensation, Perkin condensation, Perkin reaction, and a Canizares reaction. And this concludes what we call the special chemical reaction. Let us focus towards the other important topics which left over with the unit 4 during the next class. Thank you all.
Thank you, sir.
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 Thank you, sir. Thank you, sir.
Any doubt? Hello, don't write your name.
Hey, ఒక్క కదా